The next thing they want us to find is the cosine of 11 pi over 8. So again, I'm going to ask you, do you know half of this? So let's take 11 pi over 8. Do you know half of this, or do you know double of this? Okay, if I know half, that's telling me to take 11 pi over 8 and multiply it by 1/2. So do you know 11 pi over 16? Or if I multiply by 2, it's like 2 over 1. Cancel those off. Or do you know 11 pi over 4? I know pi over 4. I don't know pi over 16. So what this is telling me is I need to use a formula where I'm doubling the angle. Okay, and that is going to be plus or minus. It's what we learned in this lesson. 1 plus cosine of double this angle, which is actually 11 pi over 4 divided by 2. So the cosine of 11 pi over 4 is, where is 11 pi over 4? Well, there's 4, and that would be back to 8 pi over 4. 10 pi over 4, 11 pi over 4 is sitting right there. Do you remember doing all that? Seems like a long time ago, doesn't it? But 4, 8, 11 would be back up here, okay? So at that point, our x values are negative, and any pi over 4 is always going to be a square root of 2 over 2, and we're negative because we're in quadrant 2. So plus or minus the square root of 2 minus the square root of 2 over 2, and then divided by 2. Okay, so just like what we saw in the last problem. At this point, all it really is just kind of working with those radicals to really get this thing all cleaned up and just working inside of there. So plus or minus 2 minus the square root of 2 over 2. It says divide by 2 or multiply by that reciprocal. So kind of like what you saw just a second ago. So plus or minus 2 minus the square root of 2 over 4. The top, we're just going to kind of leave it all with a radical inside of a radical, and the square root of 4 there, we'll write it as 2. Okay, so at 11 pi over 8, where is 11 pi over 8? That tells you to divide your hemispheres into 8 equal parts. So 4 up, 4 more, so 4, 8, 12 would be back to there, so 11 has got to be right in there. And it looks like a cosine, the x value down there or to the left, is definitely going to be negative. So final answer of a cosine of 11 pi over 8 is going to be negative square root of 2 minus the square root of 2 all over 2. Let's box that up and we're done. And you know we're almost done with the lesson when you arrive to the identity part. So let's see how good these things can go. X on the left, 2x's on the right, so now I'm increasing my angle. We don't have a formula for cotangent, but we know that cotangent is cosine squared over sine squared. Okay, I can rewrite cosine squared x, and this is using our formula now without the square root signs. So it's going to be 1 plus cosine of double that angle over 2, and then the sine 1 is going to be 1 minus cosine of double the angle over 2. Okay. We have 1 plus cosine of 2x over 2. I'm going to go ahead and multiply by the reciprocal of the bottom fraction. It causes those 2's to go away, which kind of helps a little bit. And then I have 1 plus cosine of 2x over 1 minus cosine of 2x. Okay. Well, that's good. I mean, it kind of got us to a fraction. We finally have angles of 2x's. And let's go to our answer. What do we need? Well, I need a 1 to be a secant, and I need a cosine to be a 1. The first thing I can see right away is let's multiply this top and the bottom by secant 2x. We should get there right away. Secant 2x times the 2 terms in the top and the 2 terms in the bottom. So secant 2x times 1 is just secant 2x. And you all can hopefully tell me here, what's cosine 2x times secant 2x? And then secant 2x times 1 will be a secant 2x. And then again, what's a cosine 2x times secant 2x? Well, these are reciprocal functions because their angles match up. So those cancel off, give me a 1. Those cancel off, give me a 1. And we actually have our answer. Secant 2x plus 1 over secant 2x minus 1. Okay, 5b. Sine squared x, sine to the fourth. Whenever we usually have a fourth power, it's always good to write it as sine squared and sine squared. So let's start there. I'm not even going to look at the right side yet, other than the fact of knowing I've got to increase my angles. I've got to double them. The formula for sine squared x, when I want to double that angle from an x to a 2x, is going to be 1 minus cosine of 2x over 2. And I've got it 2 more times. So 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. So this first fraction, I'm going to leave it as is because it's just by itself. And over here on the right, I'm going to FOIL the top, and that way I have the bottom is 4, just multiplying that out. So 1 times 1 is 1. Outsides would be a negative cosine 2x. Insides is a negative cosine 2x. And lastly, a negative is a positive cosine squared 2x. Okay, again, whenever I'm multiplying or doing any of this algebra, your angles don't change the sign. You're only going to work with like the coefficients in front. Meaning like, let me show you this. What I was meaning by like the coefficients in front. When I want to add or go a negative cosine 2x and negative cosine 2x, the cosine 2x parts just tell you that you're common, so you're going to write that as a minus 2 cosine 2x, okay? So when you're working the algebra steps here, you never change your angle. So when I multiply cosine 2x times cosine 2x, I just made a cosine squared 2x. I didn't change my angle, I just wrote it as cosine squared. When I combined these two together and never changed my angle, I just said there was 2 of them. So that's what I mean, is the only time you can ever change your angle is when you've got an identity to help you out there. Alright, so let's keep working. We have 2 fractions. They already have a common denominator, so let's go across the top. 1 minus cosine 2x plus 1 minus 2 cosine 2x plus cosine squared 2x, all over a common denominator of 2. Alright, you know what? They don't have a common denominator, do they? I'm looking back here. 2 times 2, since there was a 4 right there, I should probably put a 4 right there. But to get them here, let's multiply that by 2, and let's multiply this by 2. So I can help maybe clean up my steps just a second. So y'all can, I bet y'all were watching that going, what is she doing? What, 2 minus 2? There we go. Okay, so now we can actually go across the top that way. Okay, so 2 plus 1 is 3. A negative 2 cosine 2x and a negative 2 more. It's a negative 4 cosine 2x. There's my cosine squared 2x. And by the time I write my common denominator of 4, then we can call this one done. Wow, you kind of have to be on top of things, right? You can't just slack off, can you? Especially not me. Alright, it looks like we're probably on our last 2, and then we're going to call this lesson done. We have a secant 4t. I'm going to leave that the way it is because we have a 4t on the right. So let's just work on changing this one right here. So it's 2 times, what would I replace that sine squared 2t with to increase it? Well, it's going to be 1 minus cosine of double 2t, which is 4t, over 2, times secant of 4t. Okay, 2 out front will cancel down there. We have 1 minus cosine of 4t times secant of 4t. Well, let's distribute this secant 4t to both these inside here. So it's like backwards distribution almost a little bit. It's kind of nice when you get an easy one in here. Well, there's the secant 4t we need. Well, cosine times secant, they're reciprocals of each other. You always get 1 right there. So secant of 4t minus 1, and there's our answer. And you know right here where I did the whole part of I could replace this with a 1, if you were ever curious, I'm not sure if y'all ever were, but if it said like cosine of 2t times secant of 4t, even though it's cosine and secant, these can't cancel and leave a 1. The angles have to match up for you to be able to take them away and put a 1 in place. So just in case you're wondering, okay? All right, let's wrap this up. All right, with this last identity, there's kind of a trick to it, so you guys are going to have to follow me through it real quick, but this is our last one. We can call this lesson finished. Tangent 2t, we don't really know anything for tangent other than the fact that we can write it as sine over cosine, and then here's the trick right here. Is not going ahead and separating these each into their own, we're going to increase these to 4t's. It's stopping just for 2 seconds. And we're actually going to multiply right from here. Oops, that didn't really come across too pretty, did it? We're going to multiply from here the top and the bottom of this fraction by something unique. It's going to be 2 cosine 2t over 2 cosine 2t. Okay? And we're going to, as we do this, it's all going to come into clear as we start looking into this. So up here in the top, let's just kind of rearrange it. Let's write it as 2. I'm going to bring the 2 kind of out to the front. 2 sine 2t cosine 2t. So it's all multiplied together. And then down here in the bottom, let's write it as 2 cosine squared 2t. All right, in the bottom, on the top, let's leave it as is. And then the bottom, I'm going to write as 2 times, and now I'm going to take this cosine squared 2t, use its formula to increase that angle to a 4t. So it's going to be 1 plus cosine of 4t over 2. Well, right there, I get to cancel that with that. So it's leaving me with a 2 sine 2t cosine 2t all over 1 plus cosine 4t. So my denominator is where I want it to be. It matches up perfectly. Let's look at the top. If I gave you this identity right here, or that sine of 4t, and I said shrink that angle by half, what would you write that out as? Looking back at a prior lesson? Well, a prior lesson says the only way to shrink a sine is 2 sine of half that angle, cosine of half that angle. Well, look to our numerator that we have right now. Don't we have the exact same thing? So really, in a nutshell, we have our answer. It's just really that part right there, that numerator, is what makes this tricky, is realizing to go almost backwards in an identity. But then we have it done, and you can call this lesson finished.